Let P and Q be real numbers. Let E denote the equation x squared plus px plus q equals 0. We are going to prove that E has two distinct real solutions if and only if p squared minus 4q is greater than 0. So this will be an example of a proof of an if and only if statement. We will first prove sufficiency. That is, we're going to prove that if p squared minus 4q is greater than 0, then the equation has two distinct real solutions. And we use this left pointing arrow to denote this direction. So we're going to use the quadratic formula. So by the quadratic formula, the solutions are given by minus p plus p squared minus 4q all divided by 2 and minus p minus the square root of p squared minus 4q divided by 2. Since p squared minus 4q is greater than 0, the square root of p squared minus 4q is real and positive. And so these two solutions are distinct and real because everything is real. And I have a plus here and a minus here. So this direction has been established and it was rather straightforward. Now let's look at necessity. So we're supposing that E has two distinct real solutions and want to conclude that p squared minus 4q is greater than 0. So we suppose that E has real solutions alpha and beta such that alpha is not equal to beta. Because the leading coefficient of the quadratic is 1, by the remainder theorem, we can write x squared plus px plus q as x minus alpha times x minus beta. And expanding this, we get x squared minus alpha plus beta times x plus alpha times beta. By comparing coefficients, we see that p is equal to the negative of alpha plus beta, and q is equal to alpha times beta. So p squared minus 4 times q is given by the negative of alpha plus beta, all squared, minus 4 times alpha times beta. And expanding this, we get alpha squared plus 2 times alpha times beta plus beta squared minus 4 times alpha times beta. And this is alpha squared minus 2 times alpha times beta plus beta squared. But this is a perfect square and can be written as alpha minus beta all squared. Now, alpha and beta are assumed to be distinct and real, and so this quantity, which is the square of alpha minus beta, must be real, and since this is non-zero, this must be positive. And this is exactly what we wanted to prove. P squared minus 4q greater than 0. So we have proved necessity as well, and that means we have proved the statement. Actually, one can take care of both directions in one go as follows. And so here's an alternate proof. As in the case for sufficiency, we're going to use the quadratic formula. So again, the solutions of E are the following. Now, they are real if and only if p squared minus 4q is non-negative. And they are distinct if and only if p squared minus 4q is non-zero. So combining the two, we get they are real and distinct if and only if p squared minus 4q is positive. Note that it is not always possible or convenient to prove both directions of an if and only if statement at the same time. But for times when it is possible, one might end up with a shorter proof. But whether or not the shorter proof is more readable is an entirely different question.